Can hear me now as well. So my name is Allan Tart, and I do work for OpenSky. And as said,
sorry, this might be. Can we try now?
Okay, now. Okay, excellent. So my name is Allan Tart, and I do work for OpenSky, and I'm really glad to see, like all the other people before me who spoke today, that there are so diverse. Set of people here in person and online, and that the work that we do in OpenSky, that it really matters to the community. And so my talk today is, so it shows that we are doing good stuff and right stuff, and my today's talk is how we plan to expand the features and the data sets that you as a community can then use for the research. This talk or this work that I'm going to present here today is mostly done by Fabian, but he's somewhere in Brazil enjoying his vacation. I'm not sure if he's online or not, but if he's not, then I think we can forgive him. But so yeah, I'm doing this presentation here because of that. Here's the outline. I'll start a little bit talk about background, why we do this new feature. And what led us to that, then what were the goals and constraints for this new feature, a little bit about architecture, how we deployed the platform, really short insight into recording statistics and quality, and also a short overview about the legislation, because it seems that the voice data is more sensitive than the aircraft data or the ADSP data. So just a quick overview about that. About the background, so in OpenSky we had to upgrade our infrastructure because the current one that we are running, it has served us well, and it has served you well, but it definitely is reaching its limits, so we needed to upgrade it. So because the new versions of components are out, and everything outdates, and we also needed a bit more resources to handle all the data loads and to develop new features. And one key element here is unified monitoring. I think most of you probably know that the OpenSky started as a research project, and it kind of grew by itself. So when looking with today's software development standards, it kind of needs upgrading. And but it, oh, sorry. Okay. And over here, you see this current state of infrastructure. So I'm not going to spend too much on details here, mainly because I'm not infrastructure guy. Fabian is, and he's not here. But we have so the patch layer, which deals with the historical data, and I think most of you use that. And we also have the speed layer, which kind of provides the live API, so you can see nice moving aircraft on screen. And on the bottom here, it's all the stuff that takes care of handling the data. So we sort of chose the phased approach. So to start with, to build up a new system with common components, with the voice recordings, because that was kind of the new feature for us, and we thought, okay, we'll put all the new stuff onto the new infrastructure. Secondly, to set up the monitoring phases 3, 4, and 5 to do performance load tests and replication of an old environment in a new infrastructure. So we pretty much take the old software components and put it on the new infrastructure and see if it works. And then on phase 6, we will switch over and we will start on a new infrastructure. And over here, you see the new architecture for that. Not all is done. I think the patch layer mainly, what has not been like migrated to the new infrastructure, but we are working on it currently. Then the second thing what happened and what led us to expanding our data set to VHF was a project called ATCO². It's an EU-funded project, and the aim of it was to develop a new unique platform for collecting, organizing, pre-processing air traffic control voice communication data. And this project ended the spring this year, and there were two main outcomes from it. The first was platform collecting and storing and distributing VHF voice recordings and transcripts, and that is what was our job in this project. And the other was the environment for manual and automatic ATC voice recording annotations, and that was done by ReplyWell. And this, so as a third main outcome of the project was nicely packaged data set, raw record that has raw recordings, annotations, some human annotations, and all related ADSP metadata. And this is available for purchase from ELDA. So in a sense, yeah, it's not that open data, but from our side, the raw recordings and the ADSP continues to be like that. And we are continuously producing new data. So if you want to expand your research from flight trajectories to include the voice part of the air traffic management, please to contact us, and we will have data available for you. Then the goals, and so that was the background. So what led us into developing this new infrastructure and the new features. And the goals and constraints, what we had while deploying the new infrastructure. So it had to be scalable, right? And OpenSky currently has around more than 1,000 active receivers feeding us with continuous ADSP data. I think it's around 1,400, but it's definitely more than 1,000. And we think that with VHF recordings at some point of time in future, we will reach the same amount of feeders. Then low complexity for maintenance and error case handling. The infrastructure should be like that. It has to be highly available. Although OpenSky is not not providing operational data, and most probably will not do that. It's not our goal. but still high availability is preferred. It has to be attractive and easy to use for new users. This receiver setup has to be easy and easy to maintain. Again, then make new data available with the voice recordings together with the transcriptions. And at some point of time, it would be nice that if those two different data sets, ADSP and trajectory data from one hand, and the voice data on the other hand, can be merged together somehow, or can be linked together somehow. That's one of the goals. And over here you see the overall cartoonish architecture that I drew. Going into details about that, so everything starts with the receiver equipment, right? And I think many of you already see it as a familiar setup. You have your antenna, low-cost software-defined radio. On this figure, it's the RTL SDR, quite popular, but I guess you can replace it whichever radio you want. And then we have all famous Raspberry Pi, but again, it's this kind of the baseline setup, and as we have seen with ADSP receivers, enthusiasts have spent quite a lot of resources, and both time and money-wise, to upgrade the setup so they can receive high-quality data from really long ranges, and we encourage that, I guess. But that's the baseline that we recommend. As a software, we recommend to use RTL SDR airband software. It's open sourced, available in GitLab, and then below the feeder software that is developed by us. It's kind of, again, rather simple setup currently. It just monitors if RTL SDR software has put some recordings into the output directory, and then those recordings are transported to OpenSky backend over the gRPC connection. Right, and I think, yeah, over time we will update and upgrade it probably some way. The backend, different layers, 4 different layers here, ingestion API. So it receives recording segments and metadata and queues them for processing. Aggregation, so from the receiver we get the raw IQ samples, and these are then transported into the backend. The backend takes care of converting those signal samples into the recording format, FLAC we are using, and it stores the metadata and does a lot of stuff. From that, the serving API will take over, and this then exports the recordings into the external annotation platform, which currently, as I already mentioned, is operated by ReplyWell, but the API between the serving API is open source pretty much. So if someone wants to do research in this domain on doing the annotating, automatic annotation, transcribing voice to text, it is possible, and it would be interesting to see how different annotating platforms and algorithms compare each other. So that is definitely possible. And yeah, again, if you want to do that, then please do contact OpenSky, and everything is open, so we will provide the API and data. And on bottom here you see the scheduled jobs, which are kind of auxiliary processes, not part of the data processing, like stats aggregations and housekeeping work. And front end, again, public, so how to access data, it should be easy and safe and secure. About the deployment, which stuff we have used. So the platform is based on Kubernetes cluster. It's capable, again, because the OpenSky ADSP part is using Kubernetes, and it is capable of scaling, deploying and scaling applications. And to set up and deploy, we have used Ansible. And on here you see on table which components we've used, and over here you see their logos also. So I'm not going to spend too much time here. Why we chose to do it like that? So because those components are open source projects which look like they will be around for a while, so they are well maintained. These are easy to install and configure and use. They are scalable because we start small, but over time we plan to grow quite big. And they have the ability to automate the configuration, so when automating things, we minimize the risk of doing mistakes, so that's good. And it obviously, those components fit the purpose, and Fabian and also John had a previous experience with those components, so that's also quite important, I think. Some recording quality and statistics as of Monday this week. Over here you see the count of recordings. So what constitutes as a recording? So when air traffic controllers and pilots communicate with each other, so it usually, I guess it starts with when aircraft enters an airspace, then they will contact a tower, or not, the air traffic controller, and they will say something. And this something that they say is in one recording. And the air traffic controller then replies that that's another recording. So it's not like the whole dialogue, they will say. So I don't know, flight Lufthansa 123 entering Dutch airspace, saying, hi, I'm here, and the air traffic controller saying, nice to have you here, and so these are two recordings then. And you see here from the countries that we have some recordings already. So by far the most recordings we have from Czech Republic. That's because the reply well who did this annotation platform is from Czech Republic. So, and the other is from Switzerland, and there I guess you also might guess what's the main reason, because OpenSky is in Switzerland. And then we have United States and so on. And over here you see the the airports that we cover, because currently we are mainly focusing on terminal maneuvering areas and airports, because over there there's most communication happening. So it's around airports. So it's not en route. From OpenSky perspective, we don't actually care too much about that. If you go home from this symposium and decide to deploy a VHF receiver and start feeding data to OpenSky, and by sheer chance you're not really close to any airports, but can receive voice communication while the aircraft are en route, flying on high altitudes, you still can feed us data. It's mostly because of, it matters more to the automatic transcriptions, because it turns out that the context matters quite a lot, and there is a bit different context in terminal areas compared with en route, although they are quite similar. And also that would be interesting to see how the automatic annotation work. So it's kind of fine-tuned, or not, it's tuned for terminal areas, but how does it behave in en route? So there's a lot of interesting things to do here. Yeah, and it's, as I mentioned, the airports. I'm not really fluent in ICAO airport codes, but maybe some of you are, so you know better. And about the quality, on lower here it's the average confidence score, to how confident the annotation platform is in its accuracy. And these are calculated on those. So there is a signal to noise ratio threshold. So when the recording signal to noise ratio is below some level, I think currently it's 3 or 5 decibels, then it's not. We are still keeping it in our storage. So because in future probably some algorithms will behave better and we can reduce the thresholds, but currently these are not being annotated. So everything, let's say, above 3 decibels is going to be annotated, and the annotation platform is giving it a quality score. And you see that the highest quality recordings come from Netherlands. I have a feeling that it might do something with TU Delft, but yeah, let's see. And then you see here that the quality does not equal quantity. So although we have most recordings from Czech Republics, they still perform high or good, but Netherlands, although not too many recordings, but the ones that we have received are really good. So that's right. Yes. And on here again, you see on which airports. I guess that's mostly to do where the receiver antenna has been deployed. So where you can see the average quality score per airport as well. Oh, sorry, exotic places, of course. Just keep in mind that it's United Kingdom and Germany, for example. And because it's a bit related with this slide now. The legislative framework. Within the ATCO project, there was a stream for legislative frameworks as well, and because it kind of feels, as the intuition says, that everything to do with voice is kind of sensitive, right? And the project looked a bit into it. And what they found was the international laws and regulations, they don't say too much about the legislative aspects of the voice recordings. So, but one could argue that the ATC VHF voice data is public data, and in a EU sense. And in EU sense, what public data directives does, it encourages the reuse and redistribution of public data, unless the data contains sensitive information that threatens public safety and security. And of course, the national legislations can override this Public Data Act. So there is a lot of ambiguity in it. And the nations then have selected very different approaches. The project looked into more than those three countries. I just took those as an examples. UK, for example, they strictly prohibit, like even operating the wireless radio station without official license. Whereas France, they don't seem to have too strong opinion about it. But the organization that the project contacted, they leaned toward it might threaten, and that's really vaguely how they phrased it. They might threaten public safety and security, because they argued from the military perspective, because the military aircraft are using the same frequencies as the civil aircraft, and there's no easy way to distinguish those two. So if you are capable of receiving the VHF from civil aircraft, you are same way you can do it for military. And USA, from other end of the spectrum, they say, well, it's freedom of information, and the FAA even provide the data on their webpage, so you can pretty much go and apply. I think it's quite straightforward application you need to fill out, and there's not too many obstacles there. But in conclusion, there's a lot of ambiguity in it, and when you wish to start receiving data, VHF data, and you are in doubt if to feed or not to feed, then you probably should contact local authorities. And it's not as easy as that as well, because sometimes it's really hard to, as with France case. So which authority should you contact? There are so many authorities, and sometimes they don't want to take the responsibility. Yeah, that's the way it is. And one place also what might give you some idea if it's okay in your country to receive and distribute the VHF data is from live ATC, for example, which I think is the biggest platform collecting the voice data currently. If someone else is already receiving and distributing data in your country and you can see it in live ATC, then probably it's okay. And I'm saying probably. So that might be a good indication. But I hope that in time those things will be worked out. The legislation will get clearer, and we will also have a bit clearer understanding what is okay to do and what is not okay to do, and we can help you also. Conclusions. We have fully functional platform collecting and distributing the VHF data. We already have the data. If you want it as a nicely packaged batch, then you can go to ELTA site and procure it from there. If you wish to have raw data, then come to us and we can provide you that with. And we do welcome new feeders and data users. So, yeah. And thanks for your attention. And